So for number 15, yeah. So if you want to find out the concentration of blue one, and blue one is right here, yeah. So 625. Yeah, you would use a 625 as the wavelength because that would be the highest absorbance for blue one. Yeah. So definitely one question that will target your understanding of this part right here. It is easy. It is about your eye exam, basically. If you're not blind, you should not miss it. An aqueous solution from
16.
if the path length of the cuvette used for the measurement is 1 centimeters, what would be the absorbance of the 1 moles? Yeah, the Beer's law, which is what? C is equal to A times B. Okay. The thing right here, epsilon or something like that.
Epsilon, it is epsilon.
So concentration, what would be the absorbance? So if you want to find the absorbance, that means you would have C over B times D.
B is the path length.
Yeah. So now, what I would say is this: if you focus on the units, they should all work out. Okay.
The C concentration.
C would be concentration, yes.
So it'd be 0.10.
So 0.100 molar is equal to A times 2.95 molar.
No, B is path length. Molar absorptivity is that.
Wait, hold on. I'm getting some error message right here. A is no, sorry, my bad. Yeah. So I realized something is wrong because if I look at the units, something is messed up right here. The molarity is right here. This is 1 over molarity. So if I actually multiply it, that becomes molarity squared. The equation is not C is equal to ABE. The equation is A is equal to EBC. So the epsilon, it's the ones. What actually, I don't even care about what those are.
No, but the path length is B. The epsilon is the molar absorptivity.
Mm-hmm.
And the absorbance is A. Yes.
But at the end, what you can see is that the units will all cancel each other out. That's how you ensure yourself, and that's how I get to appreciate the real dimensional analysis. So that means the absorbance will be 0.295, which is basically multiplied by 0.1. Okay. And then number 17, a graph of absorbance versus copper 2 concentration is shown to the right. If the absorbance of a 200 milliliter solution of an unknown concentration is 0.7, so 0.7 is right here. How many moles of copper 2 sulfate aqueous does the 200 milliliter sample contains? So we can easily obtain our concentration of copper 2 plus ion, which is 0.3 molar. Since copper 2 ion and copper 2 sulfate is in the ratio of 1 to 1, so that would also be the copper 2 sulfate concentration. But that's a concentration that is not our moles yet. So to get our moles of copper 2 sulfate, we will do molarity times volume. M times V.
Why do we know that the concentration versus the
1 to 1 ratio.
Yeah.
Because there's only one Cu in Cu SO4. Okay, so that's how you can get the number very easily. Don't even need to use a calculator.
Can you
Which part?
like the errors for this? Like, okay, this one is it at point
The absorbance.
is less concentrated because the dot is below the line.
Mhm.
So that makes sense. But why like
So the
for
dot.
more-
Now, if it's more than a line, then it's likely to be caused by the maybe like grease because it absorbs more than expected.
Yeah, that the smudges on the curve.
Yeah.
That one makes sense if it's absorbing more. But why is using too much stock solution or too little water?
So basically, what they're saying is the standard solution is not really the standard. So now the understanding, the presumed knowledge is that when we generate a curve like this one, we will use standard solutions of different concentrations. And when we say standard, it has to be done very strictly, very accurately, like to a few decimal places, or a few significant figures, that it is exactly the concentration that we desire. Like 0.1, 0.2, 0.3, 0.4, for example. Okay. So if it is less, the only thing that would be less, I mean, something's wrong with the solution. Okay, because everything else is everything else they fall in place to the straight line. So it doesn't seem like the wavelength is a problem. Okay, if it is higher, then maybe the smudge or the grease on the cuvette could be the cause. But if it's below, yeah, the solution is messed up. Yeah, the solution is messed up.
Because this is gonna ask you like lab data questions, and it's gonna ask you calculation.
Yeah.
I think this might be the FAQ.
Yeah, this is likely to be FAQ, I would say. Yeah, I agree. I concur.